Okay, I'm going to run you through the process for naming an ionic compound. Okay, I'm going to give you some rules to follow, and then we're going to do some examples. So let's go through our first rule. The first thing you want to do is just make sure it's ionic. So we're going to make sure it is actually ionic. Or mostly what we're going to say is figure out what type of bond it is. But this we're going to know it's ionic. So really what I'm saying is just check and see. Make sure that it's metal and nonmetal. If it's nonmetal, then it's covalent and you have to follow those set of rules. If it's polyatomic and a metal, then you have to follow those set of rules. But for this, we're going to say just make sure it's ionic. Okay. Now, the second step, and that's going to be our first step for the actual name, is whatever this name of the metal is here, write the name of it. So we're going to write the name of the metal. So write the name of the metal. And our third step is to write the name of the nonmetal. This one right here, write that name of the nonmetal, but we're going to add IDE at the end. So write the name of the nonmetal with IDE at the end. Okay, so there's your 3 steps that you'll want to do, and we will actually go over some examples. So let's start off with lithium and phosphorus. Okay, that's what we're going to do, lithium and phosphorus. Well, write down the name of the metal. Lithium. Okay, so there's lithium, and I'm going to write down the name of the nonmetal with IDE. That's going to be phosphide. You don't want to write down phosphoricide. You want it to sound right. So phosphide. That sounds right. Or it sounds better anyways. Okay, let's try another one. Let's go with aluminum, and we'll stick with phosphorus. Well, push pause. Try this on your own. Okay. Aluminum. And we already know that it's phosphide, so it's just aluminum phosphide. Okay. Let's try a third one. C. This time I'm going to give it to you as words. Nickel and oxygen. Okay, if nickel and oxygen are bonding, then it's going to be nickel oxide. So there's 3 examples. Simple ones too, because I didn't really try to trick you, but you just identify metal and non-metal and then you name it out, putting the IDE. There is, though, just like everything else, there's always a trick. Or not a trick. Something that's going to make it a little harder, and that something is called stock numbers. Stock numbers are on your ion sheet. Okay, so here's my ion sheet. A stock number is anything that's got a Roman numeral on it. And I want you to, and I'm sure you've done this in class already, if you haven't, you highlight everything on your ion sheet that's got a Roman numeral. Those are stock numbers. Anytime you ever run into an ionic bond that happens to be one of your highlighted ions or your stock numbers, you know that there's going to be this stock number trick. Okay, so here's our trick for stock numbers. Let's say you're told that you're working with iron 2 and fluorine. You want to bond them. So you don't have to look anything up. All you're going to do is, again, you're going to call it iron fluoride. Not that tough, hey? It gets a little tougher. Oh, did I ever make a mistake here? This is the whole point I was trying to make. That is actually wrong. The right answer is you have to call it iron 2 fluoride. That's the right answer, so that's wrong. Let's try another one and see if I can get it right. Let's go with Hg and N. Right now, you'd look in your back, you'd go, oh geez, here we go. I've got mercury, Hg, is on the back here. It's a stock number. So, that will end up being mercury 2 nitrogen. Okay, so you have to put your stock number in there. I think I got that one right. Awesome. Now let's try one more. Let's go with Sn and O. Pause that and see what you do. Awesome. Hopefully you got an answer here. Well, this is tin and this is oxygen. This, if you flip over to your ion sheet, you'll notice that tin can be tin 2 or tin 4. Which one is it? Well, we don't know. Is it tin 2 or is it tin 4? So really what we have is two possibilities. We can call this thing tin 2 oxide or tin 4 oxide. Well, quite honestly right now, because we have no idea how they want this thing combined, those are the two possible names. But had you been told that this thing is going to be a compound, SnO2, well, now you can actually say which one of these this is, and you have to do something called reverse engineering. What you need to do is you need to So, okay, like I was saying, what you need to do is something called reverse engineering. That means that you want to show all your possibilities of what actually this could be. So you have, if you look at your ion sheet, you've got a possibility of tin 2 and tin 4. So Sn2 plus and Sn4 plus. So let's go Sn2 plus. That's our first one. Well, we have oxygen. We know oxygen has to be 2 minus. And we have this way here. It could also be Sn4 plus O2. Now, we've reverse engineered the two possibilities. Crisscross them and see which one actually turns into this. Crisscrossing these, that's going to be Sn2O2. The 2's cancel. SnO. That is not that. Crisscross these. Sn2O4. 2 and the 4 can simplify down to SnO2. There. That is that. So it's going to be tin 4 oxide. So this is our answer for the name. This would be wrong. Okay? Let's try another one on our own. What I want you to do is I want you to try to name Cr and S. So push pause, give it a try. Okay, what you need to do first of all is you're always double checking to make sure that the Cr isn't on here somewhere as one of our highlighted ones. And here it is. It's chromium. So it's either going to be chromium 2 or chromium 3. So it's either going to be chromium 2 or chromium 3. And then the S is sulfide. So sulfide. Sulfide. There. Well, we would need to know what the Cr and S is as a compound, and I didn't tell you that, so you probably couldn't figure anything out when you paused it. So let's say that it is actually CrS. Okay, that's the compound. So in this compound, which one of these two names is going to be right? Reverse engineer. Two ways we could go here. We can go this way. With the chromium 2, that's going to be Cr2 plus. That's a nice thing about these stock numbers. Whatever that number is what your ionic charge is. And sulfur if you look at your periodic table, sulfur is in the 2- column, or you could also look on your ion sheet in the negative ion side under sulfide. It's already pre-named for you. Well, there it is as a 2-. So it's going to be 2-, oops, that's a minus, or I can go chromium 3, Cr3 plus S 2-. Now, read crisscross them and figure out which one of these is going to be right. Cr2, S2, the 2's cancel out to Crs. I know this is right, but I'll just double check this one. Cr2, S3, that doesn't cancel out at all. So this is the right crisscross, which means that it was the 2, so it's chromium 2. Chromium 2 sulfide. That's your right answer. That one is wrong. There you go. Hopefully that helps.